All right, so today the video made for this class will be about lesson 2 quiz on Unit 6. This is to help those of you that maybe didn't do as well. So I'll be going through each one of the problems. So to get started, the first problem we're going to be doing is computing the length of AC. Now, just like in any other video, if you know parts of this, skip ahead to the part you need. You don't have to watch the whole thing. You can just watch parts of it. So here we go. If we're going to find AC, we can call that x. Now, when you're looking at this particular triangle, you realize you have two of the sides, so you can use Pythagorean theorem. Well, when using Pythagorean theorem, you have to realize that the 13 is the hypotenuse. These are both the legs. So what you're going to use is the idea that 13 squared equals 12 squared plus x squared. Now solving 169 equals 144 plus x squared. Subtract from both sides, you have 25 equals x squared. Now if you take the square root, you realize that 5 is equal to x. So AC is the length of 5. So now we're going to take on the next part of the of this problem, part B. So just to review, the sine, cosine, tangent. You recall the SOHCAHTOA. So means that you have the sine is the opposite over the hypotenuse, ka. So cosine is the adjacent side over the hypotenuse, and TOA, in this case, means you have the tangent is the, I should have a theta in each one of these. Is the opposite over the adjacent. So we're going to first start out with angle A. When you look at A, this side right here we found out was 5. This 5 is the adjacent side. The 13 is the hypotenuse, just as before. The 12 is opposite the angle A. It's across from it, so that's opposite. So now if you just look at sine, sine is the opposite over the hypotenuse. Opposite side of A is 12. Hypotenuse is 13. You do not have to change that to a decimal or go beyond that. The cosine of A. Cosine is adjacent over hypotenuse. The adjacent side is 5. The hypotenuse is 13. Tangent, opposite over adjacent. So, opposite side is 12. The adjacent side is 5. There's your tangent. Now, when we do the second part here, we're going to move to angle B. Notice these are all B's. There's B. So, in that case, now, we are looking at the sides possibly changing. And in this case, we still have the hypotenuse being the same. The 12 now is not the opposite. It is next to the B, so that has become the adjacent side. And likewise, the 5 is no longer adjacent. That has become the opposite side. So if we talk about the sine, we have the opposite over the hypotenuse. That's 5 over the hypotenuse is 13. Cosine, that's adjacent over hypotenuse. Adjacent side now, looking at the red, is the 12. Hypotenuse, 13. Tangent, opposite over adjacent. The opposite side now is the 5. The adjacent side is 12. So now you have that you figured out each one of those trig functions. So that's for the second problem. All right, so moving on to number 3. When you look at this, they're asking you to basically, it says to a flagpole and a transit are pictured to the right. So just reading there, sketch and label the vertices of a right triangle with a right angle that could be used to measured by the transit, a side that could be measured with the tape measure, and a second side that is nearly the height of the flagpole. It says name the angle and sides that fit the above description. So what they're asking you to do is basically just draw in a picture here That looks something like that. We have the transit that's going to measure nearly the height of the flagpole. That's this side, or would be the side over, the length of the flagpole. Across the bottom, here we have, basically the distance you can measure with the tape measure, and then you have the angle that can be measured by the transit. So you're supposed to label the vertices. Label them however you want. I'm choosing to label them in that order. Now we're talking about the angle measured by the transit. That's in the bottom quarter. That's right down here, right? If we think of that as theta, that's B. The side measured by the measuring tape, that is going to be BC, or you could call it CB, it's up to you. And nearly the height of the flagpole, that's AC or CA. Now, maybe you would use, you could also write this as, hey, that's the theta if you labeled it with theta. BC you could call the adjacent side. And then you could call AC the opposite as well. So you could pick either one of these two groups really as a labeling for it. It's completely up to you. But what they're trying to get you to do is to set up for the next problem, really, so that you understand the triangle that's involved. So we'll move on to that problem now. So in this case, basically what we want to do, it says that Rita's using a transit 1.6 meters off the ground, or 1.6 meters high, 12 meters from the flagpole on level ground. So to site the top of the flagpole. All right, so the transit is actually looking at the flagpole. All right, it's 12 meters away. And what they're also telling you is this height right here is 1.6 meters. Now, it's also telling you the angle of elevation. The angle of elevation to the top of the flagpole is 58 degrees. 58 degrees is going to be this angle right here. Remember, angle of elevation is the angle you're looking up at something from the level ground. So what we're supposed to figure out is the height of the flagpole. In order to do this, we can simply label the opposite side here X. That's what we're interested in. So to start with, we realize what we have in our triangle. If I'm just going to re-sketch it below, you have 58 degrees here. That's 12 meters. Here's your X. What we have, this side is the adjacent. This is the opposite. So what we really have is the tangent function. The tangent of 58 degrees equals the opposite, meaning X, over the adjacent, which is 12. Now in your calculator, you can put this over 1. Take 12 times the tangent of 58, and when you multiply this way, you're going to get X. So you get about 19.2 equals X. Now, and that's not quite the height of the flagpole. Remember, we've got this little piece up here. That thing is 1.6 meters off the ground. So you have 19.2 plus the 1.6. You have 20.8 meters. That would be the idea to get the height of the flagpole. So any one of these problems, if you're still struggling, feel free to stop in before or after school and we can go over it. Or else this is a quick review of each one of the problems. Monday you will have the opportunity to retake this full credit, based on the score that you would receive if it is higher than the previous day.